All right, guys, good afternoon. I'm going to go over a problem on how to do confidence intervals for proportions. Um, so I have a situation and some steps, and we're just going to follow through. And I'll also be making another tutorial video on how to use confidence intervals to find means, but today we're going to look at proportions. So the situation is that a sociologist wants to create a 95% confidence interval to estimate the true proportion of adults that use Snapchat. He's going to do this by taking an SRS, a simple random sample, of 174 adults, and he finds that after taking that sample, that 56 of those adults use Snapchat. So for these problems, there's 5 steps that we want to do every time. It'll make your life easier if you structure it like this. So we want to first state what parameter we are estimating. And so this is the thing that we don't know and that we want to try and estimate because we don't know it. So if we read the problem, you'll usually gather it from that, but it says that sociologist wants to create this interval to estimate the true proportion of adults that use Snapchat. So this is the parameter that we're estimating. The parameter is the true proportion, and remember that this is for a population, the true proportion of adults that use Snapchat. So that is our parameter. It's what we don't know, and hence we're going to use a confidence interval to try and estimate it. So we're done. That's all we have to do for state. We just have to say what the parameter is, and we're good. The next part is identify. So we need to identify the relevant components for this problem. So first of all, we want to look at our sample proportion. So we're going to find the proportion that it gives us from the sample. So they took a sample of 174 adults and found that 56 used Snapchat. So the proportion that we're interested in is going to be 56 out of 174. So our sample proportion, remember, is denoted with this p hat. Our sample proportion is 56 over 174. Okay. That is our sample proportion. You can turn it into a decimal if you want. I will grab my calculator real quick. It would be helpful to have your calculator when you start these problems, so I apologize for that. So this decimal is 0.32, we'll round the third digit, 322. If you get 0.321, it's not going to make a huge difference, okay? So this is our sample proportion. Our sample size, we can get straight from the problem. We're looking for how many people he actually took a survey of or a sample of. We use that as the denominator for a proportion. This means that sample size, which we denote with n, is just 174. And finally, the last thing that we need to do for this step is to identify our confidence level. Our confidence level is given to us at the top of this problem, and it's 95%, so we'll write C equals 0.95. So this is how confident we are, or we want to be in our confidence interval. Okay, so that is the identify stage. We're done with that. Next is plan. In the planning stage, we are going to check our 2 conditions to make sure that we can properly use this interval. So the 2 conditions are the 10% and the large counts condition. So the 10% condition, remember, tells us that our sample size, which is 174, has to be less than 10% of the total population that we're looking at. So our total population that we're looking at is adults, the number of adults. So we need 174 to be less than or equal to the big sample size, the total number of adults in the world. It needs to be less than or equal to that number over 10. If we do some algebra, this means that we're going to multiply 10 on both sides, so we get that 1,740 has to be less than or equal to n. So what this means right here is that we are okay if the adult population is greater than or equal to 1,740 people. Obviously, there's 8 billion people in the world, most of which are adults. So we are going to easily meet this condition. 174 is way less than 10% of the adult population in the world. So our 10% condition, we are good. So we'll do a little check mark there. So 10% condition has been met. The second thing we need to do is check the large counts condition. And that says, remember that n times p, well, n times p hat in this case. So our sample size times our sample proportion has to be greater than or equal to 10. And then our n times 1 minus p hat also has to be greater than or equal to 10. Okay, so we do n times p hat. That would be, our n is 174. Our p hat is 0.322. 0.322. If you're clever, you'll notice that this is just an arrangement. What we have right here is just going to be a rearrangement of this. So we know that 174 times 0.322 is just going to be 56, the number that we actually got in the sample. And if we do this bottom one, we have 174 times 1 minus p hat. So 1 minus 0.322 is 0.678, which is really going to just be the number of adults that don't use Snapchat from the sample, which means that this n times 1 minus p hat is going to be 118. Both of these are greater than or equal to 10. You should be able to see and right away notice that. So those are both greater than or equal to 10, which means that our large counts condition is also met. So we are good for the planning stage. Our conditions have been met. We're going to be able to make a confidence interval without any problems. So now remember that our confidence interval is composed of our point estimate plus or minus our critical value times our standard error. So we already have our point estimate. We have our sample proportion is 0.322. We don't have our critical value yet, and we haven't calculated our standard error. Remember that the margin of error is just these two things together. So these two things combine to make the margin of error. But our critical value we don't know yet, and to find this for proportions, we're going to use our tables, or if you have it memorized by now, which is what I'm going to do, you would draw up your normal curve, and you know that our confidence level is 0.95, so we want 0.95% of our area to be in here, which means that there's 0.05 outside of these bounds, which means that split evenly, there's 0.025 here and 0.025 there. Next, using our table A, or our normal charts to find our z-scores, we're interested in this, which means we have to consider this total area right over here. So both of these two sections. That means that our critical area is going to be 0.025 plus 0.95, which is 0.975. On your tables or in your calculators, you would look for the z-score that corresponds to 0.975, which if you've been doing this enough, you would know that our z-score from that is going to be 1.96. So that's our critical value. So the last thing we have to calculate is our standard error. Our standard error for proportions looks like this. It's similar to what we did last chapter. Our standard error for proportions is just going to be the square root of p hat times 1 minus p hat over n. So we have the only variables in here are p hat and n, which we already found up here. That's why we did the identify step, so that we don't have to freak out about what those might be. So if we plug those in, we get the square root of 0.322 times 0.678. 0.678 is just 1 minus p hat. Remember, we calculated that up here. And then our n is 174. So we plug that into our calculators. Find that 0.322 times 0.678. Divide that all by 174, and we're going to take the square root. We get, on my bad calculator, 0.0354 is our standard error that we'll use. So 0.0354. So now we have our standard error, we have our point estimate, and we have our critical value, which means that we can actually construct the interval. So we have p hat plus minus z star times standard error. Plug those things in, we get 0.322 plus and minus 1.96 times 0.0354. Which you can simplify that. You should simplify the right side. I'm running out of space, so I won't do that, but you would multiply these two things together, and that would be your margin of error, remember. So now, actually, I'll end up doing that. So we want to calculate the lower bound. So we're going to calculate the lower bound, which I'll demark with LB. Our lower bound is going to be 0.322 minus this product, the product of those two numbers. So we have 0.322 minus 1.96 times 0.0354. Be careful with your parentheses when you're doing this. So our lower bound is going to be 0.253. And our upper bound is going to be 0.322 plus what's to the right of that, 1.96 times 0.0354. And our upper bound is 0.391. Okay, so this is our interval. So our interval runs from 0.253, 25% of adults, to 0.391, about 39% of adults. So now we've done everything that we need to do to create the interval, and now all that's left is interpreting it. So we have a script for that. You guys should memorize that, especially for the test. It's pretty straightforward, but we're just going to say we are 95% confident that the interval from, and then our interval is what we found right there, from 0.253 to 0.391 captures, and then captures what we were estimating, so our parameter up here. So we're just going to basically take that, captures the true proportion of adults that use Snapchat. And that is our interpretation. Hopefully you guys can see that. So this is how you would approach any interval creation for proportions. What we're going to do for means is very similar, the same structure with just some different formulas and stuff that we have to use. But this is an overview of how we would construct a 95% confidence interval, or any percent confidence interval, to estimate a proportion. So I will post this video on my website, and the other one for means will be up there shortly. So watch this one, watch that one if you need to. Our test is on Wednesday. So prepare yourself by watching this, tell your friends, and have a good day.